Okay, so here's a trick which my tutor just now told us. So I'm going to be trying to prove this trick. So we define I sub k comma n as the summation which goes from r equals to 0 to n of negative 1 power r power k ncr. And here ncr is the binomial coefficient. Okay, and we have to prove that ikn is 0 if k is less than n, and it's this thing negative 1 power n to the negative 1 power n times n factorial if k is equal to n. So how can we prove this? I think we can do this easily using induction. Okay, so let me try. So I k plus 1 comma n, that thing is going to be the summation from r equals to 0 to n negative 1 power r, and here you should have r power k plus 1, which is r power k times r, which I'm going to write as n minus r, and you got this ncr stuff. Okay, so this thing can be written as n summation from r equals to 0 to n negative 1 power r, all right, r power k ncr, and minus the summation from r equals to 0 to n. It's supposed to be n minus r, I think. All right, n minus r, then negative 1 power r power k, and ncr. All right. So now what? I'm going to write this ncr as n minus r, right? So ncn minus r. Okay, so you see that this thing, actually we know what that thing is. That thing is just n times I sub k comma n, right? We define it like that. And what about this thing though? So you see you have n minus r over here, and over here you also have n minus r. Maybe we can do something from that. So it's like negative summation. First of all, think what would happen if we put r equals to n into this term. We are going to get 0, right? Because here you got this n minus r stuff. So I can just write this thing as the summation from r equals to 0 to n minus 1, and I can write this thing as, I think, yeah, I can write it like this: n upon n minus r, n minus 1 c r minus 1, sorry, c n minus r minus 1. Okay, and you got this n minus r over there, and the remaining stuff, which is negative 1 power r and r power k. So this thing cancels with that. Nice. So this is going to be equal to n I sub k comma n. Okay, and negative, I can get this n out, so negative n times the summation of, so let's see what we got, negative 1 power r, okay, r power k, yeah. And what about this thing? I'm going to write it as n minus 1 cr, right? I mean, they are the same thing, and this is from r equals to 0 to n minus 1, right? That should make sense. And looks like we know what this thing is, right? So if we look at this definition, wait, not this one, if we look at this definition, you can see that if we replace n by n minus 1, we get exactly this thing. So this should be n I sub k comma n minus n I sub k comma, if we replace n by n minus 1, we should get this thing, yeah. So what we just did is that we actually got a recursion over here. So I sub k plus 1 comma n, that should be n times I sub k comma n minus I sub k comma n minus 1. Okay, so here's where this induction step comes in, and you get this choice whether k is less than n or k is equal to n or stuff like that. Okay, so why this choice though? So let's see. So if we put the value of k as 0, we should get I 1 comma n, that is n, and then this is I 0 comma n minus I 0 comma n minus 1. Okay, so in order for this thing to make sense, you should have n minus 1 being positive, which means n minus 1 should be bigger than or equal to 1, which means n should be bigger than or equal to 2. Okay, and you can notice that if that's the case, then this thing I 0 comma n, well, we know what this series is. It's just the summation from r equals to 0 to n of negative 1 power r and cr, which we know turns out to be 0. So this thing is 0, and similarly this thing is also 0, because you have n minus 1 in place of r, n minus 1 in place of n. So there's not a big difference. This thing is also 0, which means that now for all n bigger than or equal to 2, and obviously being natural numbers, we get the following. We get I 1 comma n is 0. Okay, so now what about I 2 comma n? So I 2 comma n, that should be n I 1 comma n minus I 1 comma n minus 1. So once again, for this thing to make sense, we should have n minus 1 being bigger than or equal to 2 this time, because yeah, I mean I 1 comma 2 makes sense, but I 1 comma 1, we don't know what that thing is. So let's just deal with the things which we know for now. So we know that for all n bigger than or equal to 3, which will make n minus 1 bigger than or equal to 2, we have I 2 comma n, that should be 0. Yeah, that makes sense. Okay, and similarly for all n bigger than or equal to 4, we will have I 3 comma n equals to 0, and so on. So like for all n bigger than or equal to, I think, k plus 1, we will have I k comma n equal to 0. Okay, so now the question is, what happens if k is equal to n? So let's see. If k is equal to n, let's just plug that thing over there. Let's plug the value of k over here as n minus 1, and let's see what we get. So we should get I n comma n is equal to n times, so you are going to get I n minus 1 comma n, okay, n minus 1 comma n minus I n minus 1 comma n minus 1. Oh, look, we know what this thing is. It's just 0. Okay, so I n comma n is equals to negative n times I n minus 1 comma n minus 1. Oh, so from this thing we can actually set off another recursion. So yeah, if you just do the inductive step thing, you will easily get this formula. I n comma n should be equal to negative 1 power, I think, n minus 1. Okay, and then you got n factorial upon 1. I mean, that doesn't even make any difference, so just leave it like n factorial. Actually, it's like n into n minus 1 all the way to 2. You are not including that 1, but that doesn't make a difference because it's 1 after all. And you should have I 1 comma 1. Okay, so now we just need to find what this constant I 1 comma 1 is. So I 1 comma 1, that is the summation from r equals to 0 to, well, n, which in this case is 1, and you got negative 1 power r power k, so r power 1 is just r, okay, and yeah, ncr. So n is 1, so it's like 1 cr. So the first term is 0 because of this thing, and then the next term is like negative, so because it's alternate positive negative, and when you put r equals to 1 in this, you just get 1. So 0 minus 1 is negative 1. Therefore this thing, I n comma n, this will be negative 1 power n times n factorial, which is exactly what we are told to prove. So yeah, that thing is done. Now you might have a question that it's okay, so you got what values you get when k is less than n, what values you get when k is equal to n, but what if k is bigger than n? Well, if k is bigger than n, then we can write k as like n plus k dash. Okay, so in that case we can write I, which is n comma k, that's equal to, so our definition, right, which is supposed to be the summation from r equals to 0 to n, and you got r power k, negative 1 power r, first of all, negative 1 to the power of r power k, ncr, right? And now k is just n plus k dash, so this is like I n comma n plus k dash. Actually, let's just write it as k, not here. Okay, so let's just write it as k over here, and over here I'm going to write it as n plus k dash. So this is like summation from r equals to 0 to n, negative 1 power r, and you got, yeah, so r power n plus k dash, ncr. So yeah, this thing just turns out to be like, you got that r power k dash and stuff, and you also got r power n somewhere, right? I mean, that should make sense. So what was I gonna do with it, right? It's definitely something which is bigger than that, so yeah. Wait, I got messed up somehow. Okay, so I don't think we can do anything from there. just leave it like that. Sure. So now we know what happens if k is less than n and what happens if k is equal to n. Though we still do not know what happens if k is bigger than n. Yeah, it's kind of a problem over there, but whatever, I will just leave it there, and I will see what I can get the solution as if k is bigger than n, and I will make a video if I do get something out of that. Okay, so I will see you in the next one.